When faced with a large set of correlated variables, principal component analysis, also known as PCA, summarizes this set with a smaller number of representative variables called principal components. Principal components are uncorrelated variables whose values are the weighted linear combination of the original values. The first principal component accounts for most of the variability in the data, followed by the second principal component, and etc. So let's consider an example. First, I need to import the health data file into the data frame. And to do that, I can go to File, Import Dataset, and then I think it's an Excel file. So I'll open up this window. We are boot of 450. Guessed correctly, it was an Excel file. So just to make things a little bit easier, we're going to rename this data frame My Data. So down here in import options, you can name things. So My Data is now the name of this data frame. You can toggle whether or not the first row represents names or not, and whether or not the data viewer is going to come up. So here we see the actual code itself that's being executed. We just kind of took the easy way out in terms of importing. Import. It's here, it's real now. We can see down in the console here that it pulled the data in correctly, and we can see in this pane the data set in the more recognizable spreadsheet format. So let's look at a few observations to inspect the data. We can do the head function to do this. And we're just going to take a look at the data. We can look at the death rate, health expenditures, life expectancy, male mortality, female mortality, population growth, and so on. And we also see there are a few more variables that were dropped off, but this might be enough to help us notice differences within the data set. We see that, for example, female mortality seems to be very high in Brazil and Cambodia. Comparatively, it is fairly low in Austria, Australia, and Canada. The death rate overall is highest in Austria. Health expenditures are fairly high in Austria, Australia, and Canada. And that seems to have some relationship with life expectancy, for example. So even just looking at the header of a data set can tell us so much. So the next thing we want to do is exclude the country name variable from the analysis, standardize the rest of the variables, and store their standardized values in a data frame called mydata.st. And we'll use the scale function to standardize the data. So we're creating something new, mydata.st. So that's something new. And we use the assignment arrow to tell this something new what we want it to be. So in this case, we use the scale function and type in my data. and -1. So what this is going to do is that it's going to scale my data, and by using -1, it's going to drop the country name variable. So we're just going to look at the remaining variables. We can't really scale variables with characters in them. They have to be numerical. So that's been done. We can see it up here in the global environment. We can take a peek at what this might look like again using the head function, just in case you're curious. Lots of numbers because everything's been scaled, so everything's going to take a value between 0 and 1. So next we're going to use the PRComp function to perform the actual PCA and the summary function to view the results. So I'm going to create a PCA object, and it's going to be based on what we get from the PRComp function. Using mydata.st. That's done. We see that it was created in our global environment. And next, let's look at a summary of our results. So here we want a summary of PCA. And now this is a lot easier to read, where we see our standard deviation, proportion of variance, and cumulative proportions. Next, we want to review the weights for computing the personal components, or the principal components. We display the rotation property of the PCA results by using PCA $ to subset it, and then rotation. So that rotated our table. To review the principal component scores, we do the same thing, but instead of rotation, we use the letter X. So again, we have a lot of data here, but we're not quite done. To list countries, our first variable, along with the principal component scores, we use the data frame statement to combine with my data with the principal component scores. Then we remove columns 2 through 13, which contain the original values in the my data frame. We can then use the head function just to take a peek at a few of the results. So let's take a look at what that code looks like. So we're going to create another object, and we're going to call it new data. We're going to use the data frame function. My data. And then PCA X, which you may remember from subsetting. That has been created. Then with new data, we want to remove those specific rows. Remember, everything in R is case sensitive, and if you do not comply with the case sensitivity, it will give you a very hard time. So new data, square brackets. For subsetting like this, it's always square brackets. The comma delineates between the rows versus the columns, and we're doing nothing with rows and just working with columns. Then let's take a look at our header. So now we have our standardized PCA values for each country, so we can see how they compare with each other. And that's PCA analysis. There are a few more examples on Connect and eCampus that'll help you through the process. This is definitely a point where data analytics starts to get pretty mind-bending, but I have every faith and confidence that you'll be able to do this with unlimited success. So give it a shot and see how it goes, and I'll catch you next time.